So we are going to be talking about the topic called projectiles. So what are we going to be focusing on this lecture? So dive into in this class. Projectile. What is projectile? A projectile is the motion of any object thrown. So just like we said project. So any object, the motion of any object thrown or released into space that travels along a what curve or parabolic pattern. Example of projectile motion, we have many of them, but let's just talk about a few of them. A thrown rubber ball bouncing on a wall. So when you hit a rubber ball on a wall, it bounces back. So that motion is what projectile. So we have an athlete doing a high jump. We have launching of missiles. So when you doing the war, they launch missiles, and throwing of javelin is an example. We have shooting of arrows with bows. We have a stone released from a catapult. We have what bullet fired from a gun. So and etc. So forth, so on and so forth. Let's talk about the terminology. So what are the terms that we should familiarize ourselves with? Those terms that if you are talking about projectile, you must always see them. So one of them is what time of flight. So what is the meaning of time of flight? Capital T. It is the time needed for a projectile to return to the same level from which it was what projected from. Please take note of that. From which it was what projected. What we call the maximum height. So what is maximum height? When that object was flying, it has a vertical distance. So the highest vertical distance it can attain when you measure it from that horizontal projection plane is what we call the maximum height. So we now have what we call range. Range is what horizontal distance from the point of projection to where the projectile hits the projection plane. Now one thing, you should have three types of projectile. The first one is when an object is projected vertically upwards. Again, object projected horizontally from a height. We have object projected at an angle theta to the horizontal. Projected vertically upward. So this is when an object is projected vertically upward. Now this is the picture of what we have. So that is what we just said. So for the first law of motion, v is equals to u plus at. Most times I prefer students trying to derive these formulas afresh so that it will help them not to be confused. So v is equals to 80. So if they ask us to find the time to get to the maximum height, you know that at the maximum height, the velocity at the maximum height is what? Zero. Talking about what? Vertical velocity. So if you put that into this equation, 0 is equals to u minus gt, since acceleration is what? Minus g. So it means that gt is equals to u and our t is equals to u over g. So this is the time it will take for the body to be released from here to go to the what? Maximum height. Now we notice that you see that the path through which the body is being projected. So from the second law, we are trying to get the formula for the maximum height. So for the formula for the maximum height, v square is equals to u square plus 2as. So including all those parameters, that v is equals to 0, s is equals to the maximum height, and a is equals to minus g. So we know that what this is going to give us was 0 square equals to u square minus 2gh, and this is going to give us what 2gh is equals to what u square. So making it a sort of formula. So our h is going to be what u square over what 2g. This represents the maximum height the projected body will reach before returning back to the ground. Note that this height is calculated above the level of what projection. That is one thing you also need to know. Okay. Now look at this example. A projectile is fired vertically upward, so we have been able to detect the type of projectile, and it's reached a height of 78.4 meters. Find the velocity of the projection and the time it takes to reach the highest point. Okay, so what we have been asked here is to find the velocity of projection. So what was the velocity which this body was released into the space, and what is the time it will take to get to the what maximum height? So solution, we first of all write the things that was given to us. We are asked to find the initial velocity, and they give us that the maximum height is what 78.4. So we are asked to the acceleration, since the body is going up, is going to be what minus 10 meter per second square, and we know that at the maximum height velocity is what 0. So this is the formula again. and we impute our values. So once we impute our value, we know that what we know that our u 0 is equals to u squared minus 2 times 10 times 78.4, and this is going to give us u squared is what 1568 mathematically, and you square root both sides. So it means that our u, initial velocity at which the body was projected, is what 39.6 meter per second. Make sure you always write the unit. Okay, so for the time taken to reach the maximum height, we make use of the first equation of motion, and we impute our values. We have already gotten the u, so remember that our solution is what minus g. So making t the solid of formula, so our time is what 3.96 seconds. So this is the time it will take for the body to reach what the maximum height. Okay, let's go to the next example. Okay, next type of projectile. Okay, this is when a body is projected horizontally from an height as shown. So if you look at this is like you are throwing something from a cliff, from a hill, or even from the window of an upstairs. So if the body is being thrown this way, one thing you should note is that for this body that is thrown out, it has two velocities. Now one of the velocity is what the horizontal velocity, and the other one is the vertical velocity. The horizontal velocity is the one responsible for taking the body forward. So, and that is what we produce, what we call the range. While the vertical velocity is the velocity responsible for the body reaching the ground, falling to the ground, and that is what is going to be responsible for the what maximum height. Okay, now you should also note something. At this point where you are releasing this, you should note that the velocity, since the body has two velocity, that velocity with which you projected it out is actually an horizontal velocity, not a vertical velocity. The vertical velocity at this place, since this place is also the maximum height, the vertical velocity at the maximum height is going to be what? 0. So it means that ux is what? 0 at this point where you are throwing it out, and so that uy is 0, while us is this value u. Okay, and we should also note that horizontal velocity is not affected by what? Gravity. So it means that the horizontal velocity is constant throughout this motion. The only velocity that is changing is what? The vertical velocity, because it is affected by what? Gravity. Okay, so now let's go for the time taken to reach the ground. Now I asked the student, for you to reach the ground, is it the horizontal velocity that will take you to the ground or the vertical velocity? It is actually the vertical velocity that will take you to the ground. So what it means is that for us to look for the time taken to reach the ground, we need to make use of what? Our vertical motion. So what it means is that s becomes what? Maximum height, which is what? The vertical height, while u becomes uy, and remember that uy at the maximum height is what? 0, and a is equals to g because the body is actually falling down. So making use of this second equation, so it's going to become h is equals to 0 times t plus what? Gt squared over 2. So h is what? Gt squared over 2. So making h making the time the subject of formula, t squared is equals to 2h over g. Remember that h is going to be the height from where you are throwing that body from. Okay, so t is equals to square root of 2h over g. Now note the difference. So the range of the projectile, how do you get the range of projectile? Now range is what? An horizontal distance. What is responsible for horizontal distance? Is it the vertical motion or horizontal motion? Horizontal motion is what will give us horizontal distance. So the range is an horizontal distance, so it is going to be given by horizontal velocity times what? Time. Why? Because since the horizontal velocity is constant throughout the motion, so, and it means that, remember, distance is equals to what? Velocity times what? Time. Okay, so ux times time, and remember that time is what? Square root of 2h over what? G. So this is the formula with which we are going to get that range. Now look at this question. They say a body is projected horizontally with a velocity of what? 60 meters per second from the top of a mass 120 meters above the ground. Now from this question, you already know that what? 120 meters above the ground is actually what? The vertical what? Height. So, and we now we are asked to look for the time of flight. So when we say time of flight for this case, the time of flight is the time needed taken to get to the ground, and we are asked for the range. So solution, they give us the, okay, this is the diagram to represent what we're talking about. So using our formulas, we have already done that before. So g is equals to, so 120 is equals to what, half times 10 times t squared. Please make sure you don't make mistake of using this u as what, 60, because 60 meter per second is what, horizontal distance, not, is horizontal velocity, not what, vertical velocity. So t is equals to what, 24 by arithmetic. So square root of 24 is going to give us what, 4.9 seconds. So for us to find the range, we just say us, that is horizontal distance, horizontal velocity times what, time of flight, and that is going to give us what, 60 times 4.9, and that will give us what, 294 meters. So the horizontal distance that this body is going to cover is what, 20, that is 294 meters. Okay. Third example, a stone is projected horizontally with a speed of what, 10 meters per second from the top of a tower. So the top of a tower is the maximum height, and with that speed, with what speed does the stone strike the ground? Okay, so for this one, so we make use of this formula. So striking the ground, we are talking about what, the vertical speed with which is going to strike the ground, because the horizontal speed is constant throughout the motion. So remember, we are talking about what, vertical motion. So we make use of the parameters of the vertical motion. So u is equals to what, 0, g is equals to 10, and the height is actually going to be the height of the tower. So this is going to give us square root of what, 1000, which is going to give us what, 31.62 meter per second. So this is the speed at which it's going to strike the ground with. So let's go to the next type of projection, which is what, the projectile that is what, inclined at an angle theta to the what, horizontal. So when a body is projected at an angle theta to the horizontal, mind you, these formulas is for what, projectile at an angle theta to the what, horizontal. So look at this case. So we have it this way. So now we have this velocity is actually being inclined, and we have what, the vertical component and the horizontal component. So this is our uy, and this is our what, us. So uy is u sine theta, and us is what, u cos theta. Okay, so if that is the case, and we see that all through the motion we have this, but at the maximum height we only have ux, because uy at the maximum height is going to be what, 0. Okay, let's go. So uy is what, u sine theta, us is u cos theta. So from the, so if we are looking for the time of flight, what we just need to do, from the first law of motion, v is equals to u plus at. So applying all this, we know that vy at the maximum height is going to be 0. So uy is going to be u sine theta minus gt. So okay, so looking for our time to get to the maximum height, gt is equals to u sine theta. So t is what, u sine theta over g. And note, what is time of flight? Time of flight is going to be 2 times the time it will take to reach the maximum height. So for this case, it's going to be 2 back. Okay, it's going to be what, 2u sine theta. So for us to find the maximum height, we use the formula v squared is equals to u squared plus what, 2as. And using that formula, applying all the parameters, we have the 0 square. So we have u sine theta square minus 2gh, making h the subject of formula. So we have that what, h is equals to u square sine square theta over 2g. So looking for horizontal h, remember that horizontal h is what, horizontal velocity times time of flight. So it's going to be what, u cos theta times 2u sine theta over g, and that is going to give us what, r is equals to 2u square sine theta cos what, theta. Okay, now for mathematics, that is the additive formula. We have sine 2 theta is equals to 2 sine theta cos theta. So it means that the range formula is going to now become u squared sine 2 theta over what g. Now there is what we call maximum range, that is to say the maximum distance a projectile can go at a given initial velocity, and that occurs at what theta equals to what 45 degree. So when we are asked for the maximum range, so sine 2 theta is going to be sine 90, and sine 90 is 1. So maximum range is going to be what u square over what g. Okay, let's get this example. Example 4. A projectile is fired from the ground level with a velocity of 500 meters per second at 30 degrees to the horizontal. Determine its horizontal range and the greatest height attained, that is the maximum height. So what height is given? Theta is what? 30 degrees, and the initial velocity is 500 meters per second. We are asked to find the range. Now from the formula we have, range is equal to u squared sine 2 theta over g. So imputing all the values, we are going to get that range is going to give us what? 2, that is 21,650 meters. So looking for the maximum height, we make use of the formula for the maximum height. So making use of the formula, we have it this way, imputing the values. So we have the maximum height to be 3,125 meters. So we are going to solve more tutorials on this, so just keep your hands crossed. So a bullet is fired at this to the horizontal. So we have this example 5. So they ask us to calculate the time needed to reach the maximum height. So theta is 45 degrees, u is 450 meters per second, g is always 10 meters per second. So they ask us to find the time to reach the maximum height, and that time is what? U sine theta over g. So imputing these values, so we are going to get our time to be what? 31.8 seconds. So these are questions you can try on your own. So thank you very much for listening to this lecture. See you for the tutorial videos on projectile.